turning the tables, and jumping over them on relational databases. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Emil Eifrem. He is the founder and CEO of Neo4j. Welcome, Emil.
Thanks.
So, what is Neo4j and what motivated you to start the company?
Good question. So we're a database company at the kind of highest zoom out level. Specifically, we're focused on connected data. The type of database that we are is called a graph database, and graph not as in Excel charts, but for example, social graph, right? So a synonym for networks. So basically what we expose as abstractions or building blocks are nodes that connect to other nodes through the relationships. And then you can attach arbitrary key value pairs called properties to both the nodes and to the relationships. And that means that we're awesome for anything with connected data. And so we're frequently 1,000 times faster or 1,000,000 times faster whenever you have operations that are centered around how things are connected compared to a traditional relational database.
So let's get into that. How are relational databases used today, and what are their weaknesses?
Yeah, that's a good question. So I think for a long time that the relational database was by far the dominant database model out there, right? And so I grew up as a professional developer in the 90s. And basically back then, when you put together an architecture, you chose some kind of a presentation layer, you chose some kind of middle layer or application server, that kind of stuff. And then you chose a database. And when it came to the database choice, it was either Microsoft SQL Server or Oracle or IBM DB2. It was basically a vendor choice, right? They all had the same data model, which is the relational model, which is focused, of course, around a tabular abstraction, so rows and columns, right? And I then think that the entire muscle memory of our industry is that, hey, we're going to take whatever data we have and we're just going to put it into the relational database. And that's what happened for sure in the 80s and the 90s, and also in the early 2000s. Then, of course, something happened where data became big enough and complex enough and messy enough, as well as the value of analyzing that data became evident enough that people started challenging that and saying, hey, you know what? Actually, we can put this data that is shaped like this in a more form that is more appropriate to that shape. And we can put the data over here that is shaped in a different way in another database that is more appropriate for that shape. That had many names. It was called, big data, of course, but also NoSQL in the early days and all kinds of stuff. But there was this rise of an alternative to the relational database. And I think that the relational database is a great piece of technology. It's a fantastic piece of both computer science as well as engineering in very many ways. And I still think that it's going to be around, decades from now, and it's going to be put to good use. But I do think we moved past the point where you put all data instinctively, habitually into the relational database. And that new world where you have a more heterogeneous type of backend, or more plural world for databases is the world that we're working towards.
So let's drill down. How did graph databases address the weaknesses that you described?
Yeah, that's a great question. So I think that the new world of data, right, in 2018 versus back in, let's say, 1988 or 78 when the relational database was invented, exerts pressure on the relational database in new ways, right? In different ways, I should say. One is just pure size. Another one is complexity. Where we fit is when you have connected data, right? And so that's, for example, let's say that you're building a recommendation engine, right? You can look at purchase history as a tabular abstraction, product ID, date, customer ID, and amount, right? This particular customer at this time and day bought the following product for X dollars, right? And then every single purchase is just a row in that table. Very uniform data, very tabular, fantastic for a relational database. But you can also take exactly that same data and you can look at it from a connections perspective. For example, hey, there's Emil and there's Tonya, and Emil has bought these 3 products. Tonya has also bought those 3 products. It seems like we share some kind of interest, like we seem to buy the same stuff, right? Now let's take a 4th product that Emil has bought that Tonya hasn't bought. At that point, let's take that and recommend it to them, right? At that point, doing that very trivial example, that's actually 12 hops, right, in that information structure. And the relational database is great at many things. For example, give me the average of all the purchases that were done yesterday or something like that, right? But it's not good at doing hops in connected data, because every one of those is a join, and the joins are exponentially performant, right? Exponentially expensive. And so that just 12 hops might take hours or something like that. In a graph database, we can do 1,000 to 1,000,000 to millions of hops per second in core.
You mentioned SQL earlier. Are graph databases SQL based, or have you created your own software at the base level?
Yeah, so there's multiple parts to that, right? So we are what's called a native graph database, which meant that we've said, hey, assuming the abstractions, the building blocks that I talked about before, nodes, relationship, key value properties, if you assume that as a surface, what is the most optimal underlying engine for that? And with a native architecture, what you do is that you then take every single underlying layer, every component, and you optimize it for your data model. In this case, for a graph model or a connected data model. And so that means optimizing your query planner, that means optimizing your query engine, that means optimizing your transaction subsystem, that means optimizing your storage engine. Everything is optimized for that shape of data and those type of workloads. That extends all the way up to your point, to the query language. So we have invented a query language. It's called Cypher, and it's the SQL for graphs, or the SQL for connected data. And it's just really powerful to succinctly express things like the pattern that I just talked about before. Hey, other people who bought this also bought that. That's a 2-3 liner in Cypher. It's probably tens or 20, maybe even hundreds of rows of SQL, right? Or lines of SQL, I should say.
How do graph databases help companies comply with GDPR?
Good question. So one of the fascinating things about a database company is that it's a very, very horizontal technology. Ultimately, we're useful wherever there's connected data and there's value in connected data. And my prediction, as the world is becoming increasingly connected, data fundamentally models the real world. As the real world becomes more connected, so does data. So I think that eventually will be everywhere. Having said that, there are some early use cases where we feel like, hey, this seems to be pockets where this is adopted earlier than in other situations. One of them is master data. And master data is typically about tracking kind of maybe what people call the meta layer about data, right? So for example, data lineage is a common and popular use case, which is tracking about where data has been and where it's going, which system it entered in, and things like that, right? Obviously, this is very related to GDPR, because fundamentally that's one of the many kind of constraints that GDPR puts on companies that are storing data, that they need to be able to do that. The good news about that is that, hey, it's all about how things are connected and how things move through your broader data architecture, and we're really awesome at tracking connections, right? And the second good news is that doing that is actually what you want to do for pure business reasons. Getting like what's called a customer 360 view, so a completely integrated view of all of your customers, is the right thing to do for a modern data architecture, and because it gives you all kinds of benefits. For example, around recommendations and personalization. And that's so solving the GDPR problem, right, also gives you all kinds of business benefits. And a graph database is right at the center of that.
Can you share a success story about a customer who implemented graph databases?
Yeah, there's plenty of that to choose from. I now know of 12 independent projects that are working to find the cure for cancer using Neo4j, which is really, really amazing. I'll choose a different example though, which is that of NASA, who was using Neo4j in Project Orion, which is the mission to Mars, where they were looking into finding engineering fixes that have been used in the past to solve certain problems. And they've been very disciplined as an engineering organization. NASA has been at recording all of their successes, but also mistakes in engineering. And Project Orion, ran into the same problems in one particular part of the machinery as the legendary Apollo missions, right? And so when they tried to find the solution to that, they figured, hey, we should look into what mistakes were made and how they fixed them in Apollo. The problem was that this lessons learned database that they recording for 50 plus years was all stored in a format that didn't really represent how things are connected. And much in the same way that Google made sense of the web for all of us was by using a graph algorithm called PageRank, so how things are connected. NASA did the same thing as they moved their data out of that old database into Neo4j. And thanks to that, they found the solution to the problem in Project Orion. And they're on record saying that saved them millions of dollars of taxpayer money, which we like, and 2 years. So basically, the humankind will get to Mars 2 years earlier thanks to graph technology, which makes me really, really happy.
Emil Eifrem, founder and CEO of Neo4j. Thank you so much for joining me and to share your discussion on database. If somebody wants to connect with you, maybe they want to find out more about your company, how can they do that?
You can always go to neo4j.com. That's NEO, the number 4, and j.com, or you can tweet me at Emil Eifrem.
All right. And thank you for watching, and find me, if you will, at ZDNet or Tech Republic, or go to my website, tonyahall.net. Thanks for watching.